So Bismillahirrahmanirrahim. Assalamu alaikum. So in this video we'll learn how we can calculate the shear strength parameters from the observations of direct shear test, or how we can interpret the results of direct shear test. So here is an example. These are the actual values of a test we performed. So we'll learn how we determine the C and phi parameters from this test. As you all know that we apply normal stresses 50 kPa, and then we record shear force and displacement until the failure. The failure means if there are two conditions regarding the failure: shear force increases, and there comes a point where it starts decreasing. So that is the failure condition. We record 3 to 4 reading after failure. The second scenario is the value starts increasing, shear force value starts increasing, but after some time it becomes constant. If it remains constant for some time, we terminate the test and we take 3 to 4 readings as well. Correspondingly, we note down the displacement values. Same goes for the other normal stresses. As you know, then we apply the 100 kPa load on the same soil sample, and then we record these values. And here is the third normal stress, 200 kPa. Then how we determine the C and phi parameters? Let's start. Firstly, I will try to make you understand the formation of Excel sheet. So we'll go step by step. Firstly, I'll convert this Newton force into stress in kilonewtons, kilonewton per meter square. So I'll insert a column, insert entire column. So here is S shear stress in kilo newtons per meter square, or kPa you can say. Yes. Okay, how we'll calculate this? We'll apply a formula: force divided by area. Area of the sample is given as 0.003. I will write it down: 0.003 meters square is the sample cross-sectional area. Multiply by 1000. We multiply by 1000 to convert this Newton value into kilonewton. So this is how it will become kilonewton per meter square. The force value is converted into stress. So this is the shear stress value. I'll confine it to 2 decimals so that it may be convenient. Okay, so these are the shear stress. Now I'll convert the displacement values into the meters. So I will insert another column, entire column. So displacement in meters. So as these values are in millimeters, so I'll just convert these values into meter. We'll divide it by 1000 to convert it in meters. So I'll drag it down. So this is how these values okay, this formula is, yes. So I'll have to increase the format cell, and I'll have to increase these numbers for this so that the value can be appear. Okay, so you can see here the displacements in meter. Same I will apply here. We will convert the force into shear stress. So shear stress, it is in kilonewton per meter square. To convert this, I'll have to apply formula divided by 0.003 multiplied by 1000 to convert it in kilonewton per meter square. Now I'll drag this one and will obtain the kilonewton per meter square. Stress values. Now I'll convert the displacement values into the meter. So entire column insert displacements in meter. So just I will click over here, we'll divide it by 1000. Yes, I will drag it down. Okay, similarly I'll do the same procedure for 200 kPa. We'll insert two columns. So I'll insert two columns, one for stress and one for the displacement. So here is shear stress in kPa. Here we'll apply the formula. This is shear stress along with that displacement in meters. So what I'll do is, again, same procedure. Select this, divided by 0.003 into 1000, and we'll drag it down. Okay, now for displacement, select this, divided by 1000. The formula is applied. Now drag it down. Okay, now firstly I'll plot stress strain curves. So for plotting the stress strain curve, I'll go to graphs, and now here select data. Okay, add. So firstly I'll plot the graph of 50 kPa. So along the x-axis there will be displacement in meters. Okay, and along the y-axis there are stress, shear stress in kPa, kilonewton per meter square. Okay, so this is first curve. Now we'll draw a second curve for 100 kPa. Along the x-axis I'll plot displacement in meters, and along the y-axis I'll select the shear stress. So here is the second curve has been added. Now we'll add along the x-axis. Same goes for the 200 kPa. It will be displacement values, and then along the y-axis there will be stress values for 200 kPa. So in this way we'll generate three curves, and the graph you can see here. So these are the stress strain curve. So the maximum value of the shear stress is the governing failure value. So what I'll do is I'll write it here. Now we have to find out the C and phi parameters. I'll write it here: normal stress and shear stress at failure. So as we know, there are three normal forces: 50 kPa, 100 kPa and 200 kPa. So now find out the shear stress at failure. So what I do is to find the maximum value of shear stress for 50 kPa, and that is, select this column, click OK. Now you can see here the maximum value is 29.67 kPa. Then again for 100 kPa we'll adopt the same procedure, maximum value from this column. So OK, and same procedure for 200 kPa, maximum, and I will select this value, enter, and we have obtained these failure values. Now for 50 kPa the failure shear stress value is 29.67 kPa, and for 100 56.667, and for 200 is 105. Now we have to plot another graph. Yes, insert, we'll select this one, select data. As you know that this graph is between along the x-axis there is normal stress, sorry, just to make you understand that. Okay, now select data. Along the x-axis we select the normal stress, that is 50, 100 and 200. Along the y-axis we have shear stress values. Okay, the graph is plotted. Now we'll edit the axis titles. You know, here is shear stress in kPa, and along the y-axis it's normal stress, normal stress in kPa. So now what we will do is we'll go to the trend line and we'll join it by linear trend line. Okay, linear trend line. So the line has been as we know that these points are joined by the best fit line. So in this case it is fortunately these points are showing the linear trend. The points can not be in a linear trend, but we have to generate a linear trend according to Bohr-Coulomb theory. So now we'll select this line, and what we will do is, okay, now we'll select this line and we'll backward, we'll click 50 and then display equation on the chart. So you can see the y-intercept is basically the cohesion. So what is cohesion? 5.5. Now here I'll write C values, that is 5.5 kPa according to law of linear equation. So what is angle of internal friction? Angle of internal friction is basically the slope of this line. So the slope of this line is 0.4995. I'll represent slope with the 0.4995. Now I'll have to convert this value into phi. Firstly, I'll convert it into radians. So how I will convert this value into radian? Apply a formula. Inverse, tan inverse. Yes, this value is in radians. We have to convert this value into degrees. So to convert this value into degrees, we have to multiply this value by 180 divided by pi. So multiply this value with 180 and then divide it by pi, that is 3.14156, and this is the value of angle of internal friction in degrees. So this is how we can find out the shear strength parameters from the data of direct shear test. So these curves are important to find out the elasticity modulus. As we know, the slope of stress strain curve is elasticity modulus. That is why it is very important. These curves are very important. So this is how we can perform the calculations. I hope you like the video, you have understood what I wanted to deliver. If you like the video, please subscribe and share. Thank you and Allah Hafiz.